Good morning, students. Welcome to the class. In today's session, we are going to discuss the solution of previous year's CDS question papers. Okay, these questions have been asked in 2025 CDS second examination. Okay, I will try to provide you very short and direct hand solutions of the questions. Okay, so we are gonna to continue providing the solutions of last 10 years questions of the CDS. Okay, so let's start. And there is a question is very interesting. Let px be a polynomial where when px is divided by x minus 1 it leaves remainder 2. When px is divided by x minus 2 it leaves remainder 1. What is the remainder when px is divided by x minus 1, x minus 2? X minus 1 multiply x minus 2. So this is the question from CDS second 2025. Question is interesting, but I wanted to tell you one thing over here. When we are dividing the polynomial px with x minus 1, x minus 2. So this is the divisor. X minus 1, x minus 2 is the divisor. And you can see x minus 1, x minus 2 is the divisor, and it will be a quadratic divisor. It will be a quadratic divisor. Always remember one thing. When divisor is quadratic, remainder may be linear. When divisor is cubic, remainder may be quadratic. Okay. When divisor is linear, remainder may be constant polynomial. So here the divisor is quadratic, it means remainder will be linear. So remainder will be like rx is the remainder, will be ax plus b. It will be ax plus b. Understand that? Now we will discuss that when px is divided by x minus 1, it is saying that it leaves remainder 2. Understand that? So I mean to say, when here x minus 1 is the divisor, so how we are gonna to solve it? X minus 1 will be equal to 0, so x will be equal to 1. We have to place x equal to 1. Now we will place the x equal to 1, then px means p1 will be equal to a multiply 1 plus b. It will be a plus b. Remainder will be a plus b, and a plus b is equal to 2 because 2 is the remainder. Okay, again, when px is divided by x minus 2, it leaves remainder 1. It means again x minus 2 will be equal to 0, x will be equal to 2. Again we are going to place the value over here. So p2 will be equal to 2a plus b, and it will be equal to 1. Understand that? Now we have two equations in form of a and b. We have two equations here in form of a and b. One is a plus b equal to 2. Another is 2a plus b equal to 1. 2a plus b will be equal to 1. We are going to simplify these equations just to get the values of a and b. I am subtracting the equations, and b is cancelled. I am going to get a equal to minus 1. If a equal to minus 1, then b will be equal to 3. I am placing the values of a and b over here. Okay, so I am placing the values. It will be minus x plus 3. So answer is 3 minus x. So option 3 is the correct answer of this particular question. Understand that? Question is quite easy, and this is the answer of this particular question. Now we are moving to our next question. The question number 2 is, this is the question number 2. The question says that let p and q be the natural numbers such that p greater than q. What is the greatest largest value of p such that q square, this is q square minus 5p minus 4 is negative. Okay. In the question it is clearly mentioned that p and q both are the natural numbers. What are the natural numbers? Numbers which are greater than 0. Means numbers which are positive integers starting right from plus 1. Okay. And it is also mentioned that p is greater than q. The value of p is greater than q. So I can say that when value of p is greater than q, I can say that, just a minute, let me check the question. I think it has some kind of minor mistake over here in the question. Let me check that. Just for a minute. I have the entire paper downloaded in my phone, so I'm checking for the question, whether the question is correct or not. I'm guessing that it has a little bit mistake. It might be q greater than p. I have to check only that. I have to check only that it might be q greater than p. Okay, okay. I got the mistake. Here p is not greater than q. It is like q greater than p. So you just have to amend this. Okay. Now I am again reading the question. Let p and q be the natural numbers such that q greater than p. Q greater than p. Then what is the largest value of p such that q square minus 5p minus 4 is negative? Okay. You know very well what are the natural numbers. Natural numbers which are greater than 0 and which are positive integers. Those are the natural numbers. In the question, it is directly mentioned that q is greater than p. Q is greater than p. Both are the natural numbers. So I can take that, I can consider it, let q equal to p plus 1. Q equal to p plus 1. Whatever the value of p is, the q is greater than p by 1. Okay. So I'm placing the value of q over here in terms of p. I have assumed that q is equal to p plus 1. So I'm writing over here uh, p plus 1 whole square minus 5p minus 4. And he's saying that the value of this particular should be negative. You know, when the value will be negative when it is less than 0. Okay. If its value is less than 0, it will be negative. So it should be less than 0. Understand? Now I'm just going to expand a plus b whole square over here. It will be p square plus 1 plus 2p minus 5p minus 4, and this complete must be less than 0. This complete must be less than 0. Okay. Now I'm going to simplify this. It will be p square 2p minus 5p minus 3p and minus 3 minus 3. It should be less than 0. Now I'm not going to simplify this equation. I will use the option. Okay, he is asking to calculate us the largest value of p. So in the options, the largest is 6. I'm just going to place 6 at place of p. So I'm going to place 6 square 36 minus 18 minus 3. 36 minus 21. It is positive, it's not negative, so it will not be the answer. Now I'm using option C, 5. 5 square 25 minus 3 into 5 minus 3. 25 minus 15 minus 3, 25 minus 18, it is also positive, not negative. So this is not the answer. Now I'm using 4. 4 square 16 minus 3 into 4 minus 3. 16 minus 12 minus 3, it is also positive, not the answer. So option A is the answer. Okay, it is the quickest approach to simplify this question. Now we are moving towards our next question, and that is going to be quite important question for us. Okay. Oh. This is question number 3. This is question number 3. Question number 3 says that let x and y be the natural numbers, each less than 20, such that x, y, x plus y, x minus y are the prime numbers. Okay. How many such combinations of x, y, x plus y, x minus y are possible? Okay. It is clearly mentioned that x and y both are the natural numbers, one thing. So x and y, each of them is greater than 0. And it is also mentioned that each less than 20. So value of each x and y is less than 20. And one more important thing is mentioned over here. X itself, y, x plus y, x minus y are the prime numbers. Okay. Now, what are the prime numbers? Numbers which are divisible by itself and one only. Okay. Those are the prime numbers. And it is mentioned that x should be prime, y should be prime, their sum x plus y should be prime, and their difference x minus y should be prime. Okay. So listen to me very carefully. When we are talking about two different prime numbers and we are saying that their sum and their difference or the subtraction must be prime, it is only possible when one of them is even prime number. One of them is even prime number. Understand that? Now, if we are saying that one of them should be even prime number, there is only one even prime number, that is 2. So either x or either y is 2. Either x or y is 2. One of them is equal to 2. Either x or y is equal to 2. Understand that? Now the question is that which one is equal to 2, x or y? I would say y. Why? Because if I'm gonna to take x equal to 2, y might be 3, 5, 7, 11, 13. but in that case x minus y is not gonna to be the prime. Okay, so assume that y will be equal to 2. So value of y is and only 2. Okay, value of y equal to 2. There is no another value for y which can be used at place of y. Understand that? Now x can be, now x can be 3, 5, 7, 11, 13 and 17. Okay, x can be 3, 5, 7, 11, 13 and 17. But we have to uh, justify that whether x plus y is gonna to be prime or not. In the same way, x minus y is gonna to be prime or not. So we are just gonna to calculate x plus y and x minus y using all these values. If I am using 3 at place of x, 3 plus 2, it is prime means 5. But 3 minus 2 equal to 1, this is not prime. So this value is not applicable in this combination, because the question is saying everything x should be prime, y should be prime, x plus y should be prime, x minus y should be prime. Here x is prime 3, it's okay, y 2 prime, okay, x plus y equal to 5, it's prime, okay, but x minus y 3 minus 2 1 is not prime. So this number cannot be considered in this combination. Now we are talking the next number, that is 5. If we are gonna to take 5, it x plus y will become 5 plus 2 equal to 7. It's good. Now 5 minus 2, it is 3. So here everything is prime. 5 is prime, 7 is prime, 3 is prime and 2 is also prime. So one combination is possible, 5, 7, 3 and 2. One combination is possible. Now we are gonna to check for 7. x7 y2, it is 9, this is not prime, so this is not gonna to work. Now we are gonna to check for 11. Okay, if we are gonna to check for 11, 11 plus 2 equal to 13, it's good. 11 minus 2, it is 9, this is not prime, so again this is not gonna to work. 11 cannot be considered in this combination. Now we are gonna to apply the conditions on 13. So 13 x plus y, 13 plus 2 15, it's not prime, so 13 cannot be considered in this combination. Now 17 plus 2 equal to 19, good. 17 minus 2 15, this is not prime, so it will not be considered in this combination. Okay, so there is only one combination possible where x, y, x plus y, x minus y can be a combination of the primes. So option 1 is the answer. Option 1 is the answer. Okay, so it was question number 3. Okay, and it has been asked from CDS 2025 second. Okay, and I have uploaded one more video on my YouTube channel related to the solution of previous year questions of the CDS examination. Okay, CDS question paper. Okay, now we are moving to the next question, and that is quite important. The next question says that x plus 2 is the factor of which one of the following? Okay, here x plus 2 is the factor of any of these polynomials. Okay, so if x plus 2 is the factor, it means x plus 2 is completely gonna to divide gonna to divide any of these polynomials. Understand that? So I will do in the same way, x plus 2 equal to 0. I will place x equal to minus 2. After placing x equal to minus 2, the value of polynomial should be equal to 0, means remainder should be 0. Okay, if remainder is 0, that is the answer, correct answer for us. So I'm gonna to place in option number 1. Minus 2 to the power 5 minus 32. Okay, and 2 to the power 4 16 into 4 minus 64. Okay, this is minus 2 cube minus 8 and minus 3 plus 24. Okay, and here 2 square 4 plus 32, this is plus 32, this is again plus 28. Okay, and this is plus 12. Understand? I have placed the values of x everywhere in option A. Now plus 32 minus 32 cancelled. Okay, you can see minus 64 plus 24, it is minus 40. Okay, and these are also plus 40. So here the remainder is 0. So option A is the answer. Option A will be the answer for this particular question. Okay, now we have the next question, question number 5th. This is the question number 5. If x to the power 4 equal to x square plus 1, then what is the value? What is the value of 2x to the power 4? 2x to the power 4, we have to calculate the value of this particular. Okay. Uh, okay. I can say that x to the power 4 equal to x square plus 1. Okay. And it can be simplified like x square, x to the power 4 minus x square minus 1 equal to 0. Let x square equal to y. X square equal to y. So it will be like y square minus y minus 1 equal to 0. Now I have to calculate the value of y only first. Okay, so I am going to use the Sridharacharya formula. Y will be equal to minus b. What is minus b? You know the formula, minus b plus minus under root b square minus 4ac upon 2a. I'm using this particular formula to simplify the value of y because it's a quadratic equation. It's an quadratic equation. I'm going to place the value of b, minus minus plus 1 plus minus under root b square 1 and minus 4ac minus 4ac minus 4, a is 1, c is minus 1 upon 2. So it is gonna to be plus. So value of y 1 plus minus under root 5 plus 2. Okay, under root 5 plus 2. And here the value of x is greater than 0. It was not mentioned in the question, but in original paper it is mentioned a value of x is greater than 0. So I'm gonna to take y equal to 1 plus root 5 upon 2. 1 plus root 5 upon 2. But we have to calculate the value of 2x to the power 4. 2x to the power 4. And it can be written as 2x square whole square. And x square is assumed equal to y. So it will become 2y square. I'm going to place the value of y square. Y square is equal to 1 plus root 5 upon 2 whole square. So it will become 2 into the 1 plus root 5 whole square. It will be 1 plus root 5 plus 2 root 5 upon 4 upon 4. Okay, so it will be like this. Okay, now 4 is cancelled by 2 times. It is 6 plus 2 root 5 upon 2. I'm gonna to take 2 common. It is 2. 3 plus root 5 upon 2. 2 is cancelled. So answer is 3 plus root 5. 3 plus root 5. Okay, it is I think it is not correctly typed. So option D is the answer. 3 plus root 5. 3 plus 5 to the power 1 by 2. This is the correct answer of this particular question. Okay. 3 plus root 5. 3 plus root 5. This is the correct answer. Understand? So it was the question number 5 from this paper. Now I have the next question. Question says that if n is the natural number less than 7. Okay, n is a natural number less than 7 means the value of n is possible from 1 to 6. Okay, then what is the number of values for which 12n plus 2 and 8n plus 2 are the relatively prime? Okay, he is saying that 12n plus 2 and 8n plus 1 should be relatively prime. Firstly, you should know that what are the relatively prime numbers. I would say that the numbers having HCF highest common factor equal to 1, only 1. Okay, the numbers having highest common factor HCF equal to only 1, those are known as the relatively prime numbers. Okay, and I mean to say if there are two different numbers and their common factor, highest common factor equal to 1, those are the relatively prime numbers. Now you can see between both these values, one is 12n plus 2, another is 8n plus 1. There is nothing common except 1. Highest common value between both these is 1. So HCF equal to 1 here. Understand that? So both these values are relatively prime values. Understand that? Now in the question it is mentioned that n equal to less than 7 and n is natural number. So firstly you are gonna to place n equal to 1. You are gonna to get two different relatively prime values, and again you will place 2, 3, 4, 5, 6. You will get 6 different pairs of relatively prime numbers because already HCF is 1. So just changing the values, the pairs are not gonna to change their property. They will remain relatively prime for all 6 values of n. So total possible values of n are 6. Understand that? So this is the answer of this particular question. Okay. Okay. Okay, in this particular video we are gonna to discuss only these 6 questions. Okay, I was planning something, but those things could not be uh, enforced. Understand that? Now I'm here with you only with the solution of these 6 questions in this particular video. In the next video I will provide you the solution of 15 to 20 questions. Okay, from next video onwards we are gonna to do this. Okay, we will simplify 15 to 20 questions in a video, and I'm going to provide you 2 or 3 videos related to the CDS every week. Okay, and 2 to 3 videos I will provide you related to the SSC examination. In those videos we are just going to discuss the basic concepts of the mathematics, especially geometry. Okay, so keep sharing, and if you are liking the things and the kind of solutions I'm providing, just share with the friends who are just preparing for the CDS or SSC. And soon I'm going to provide you the videos related to the solution of 10th class mathematics. Okay, thank you so much, and please keep sharing the videos. Thank you, Lord.